Good day. Today we're going to be focusing on finishing up this caster design problem. We've created the top plate along with the two vertical arms. We have to create the wheel and the shaft, which won't take long. Add those into the assembly, and then we're going to walk through the process of exploding the assembly and then creating some detailed drawings, potentially in a third video as this process goes on. Alright, so we have to create the shaft and the wheel. So creating the shaft is actually going to be somewhat easy. We're going to create a new sketch on the side of this object. We'll create a circle based on the other circle. And so now we've got, let me flip this around so we can see it. So now we've got a circle that's been created on this arm. We're going to finish the sketch. We're going to do an extrude, but what's unique about this is that we are going to select the circle. We're going to select the direction of extrusion. Since I copied it, copied that. Nice. So that is pretty interesting. Since I made this as a copy, it took that same feature and copied that. So we have to back this up. Things don't always work the best way. So what we're going to do is, instead of creating a sketch on that object, we're just going to draw a circle out in space and dimension it 1/4 inch. And as we create our object here, there we go. We know that this is 1 point, well, we're not sure again. Let's hit the inspect button. We're going to inspect it from this arc to this arc, and it's 1.125. So we finish the sketch, we extrude the circle, comes back negative 1.125. Boom. So now that's an object as a body. So if you want to slow click on the body, we'll call that shaft. And then we need to convert this into a component. So now the shaft is a new component. And finally, we've got one more object to create, which is the wheel. And so I'm going to create a vertical object, the wheel, just draw it off to the side here. The wheel has a diameter of 2.5, and it has an interior diameter for the shaft at 0.25. And we're going to finish the sketch, and we'll flip it around to the 3D view, extrude this. The extrusion of this is 3/4 of an inch, 0.75. Okay, so it's pretty basic. We could chamfer the edges and make it a little bit cleaner, but the whole idea is it's just a basic object. But it's not an object that we can constrain yet, or excuse me, it's not an object that we can assemble yet because it's still considered a body. So again, we're going to call that wheel and create a component for it. So now that it's a component, it can be moved around. Okay, so again, aligning and constraining. So we're going to create a joint and capture the current positions. So this point on the wheel is going to be connected to the interior side of right there. But we need to offset it, which is fine, and we'll get to the offset here in just a second. So those two are now connected, but we need to offset it let's see here, it's 1 inch, 3/4, and 1/8 inch on both sides, so 0.125. And if you want to check it, we can look at the left side view here and confirm, an 1/8 inch is too far. So instead of an 1/8 inch, it needs to be a 1/16 of an inch, 0.0625. And 0.0625 gives me an equal gap on both sides. So again, changing your view is really important so you can see exactly what's happening here. All right, I like that. We'll choose OK. Now the shaft. Same scenario. We'll use the joint command, highlight the end middle. We'll highlight the end middle here because we know that the shaft will go all the way through. And it connects in and it's rigid. And if we flip to the other side, we should see that it goes all the way to that edge also. So it does. All right. So a couple of things. Number one, we can change the appearance of these, and we can either change the properties and materials, but realistically we can just change the colors if we wanted to. And in this case, we're just going to use some glossy paint colors here. So we'll make that yellow. We'll make those red. Dark gray on the wheel. And we'll leave the top gray. All right. So now we've dressed it up. We've given it a little bit of color here as we go along. Oh, so yellow didn't hold. So why didn't yellow hold to both? Did it just apply it to the face? Remove appearances applied to faces. Yes. So that should now be applied. I only applied it to the face as opposed to the object. So there we go. So we have the yellow shaft and the darker objects and so forth. So we're all set. Well, congratulations. We're now done. Make sure you hit the save button. And that's one thing that you want to make sure is that that you save often. Now, granted, the nice thing about Fusion is that it does do automatic saves for you. But at any major juncture, you want to do the save command. All right, now that we've saved it, let's talk a little bit about creating a drawing. And then we'll deal with the exploded view drawings also. Actually, let's do the exploded view first, and then we'll deal with the drawings. So like anything within the Fusion 360, we have different tools to use. And in this case, we're going to use the animation tool to create the exploded assembly. And so the animation will have our tools in the bottom. And what we're going to have to do is figure out how this object will be disassembled. And that's really important because you want to disassemble the object in the order that you expect that it would be assembled in. So you have to think through the manufacturing process, the assembly process in the manufacturing. So in essence, we want to move components. And so we have a storyboard that's been created here. And we can go ahead and move. And I want to select the shaft. Okay, so I want to pick the shaft because that's going to be the last thing that gets placed is the shaft. We're going to move the shaft. So that shaft, and I can grab the arrow that we want to move it. I'm going to go ahead and move this shaft, and we'll say we'll move it 3 inches. And I like typing in the distances so they're exact. So we'll choose OK. So you'll notice that the shaft now has a move component. And it took like 1 second, which is horrible. So we'll say that it actually will take a total of 10 seconds to move the shaft out instead. And so as the shaft moves out, it takes 10 seconds. The second component that we're going to move is the wheel. So again, we'll choose wheel, we'll choose move. We'll select the wheel. And now I've got to pick XYZ movements. So I know that the wheel can come straight out and then go down. So we'll kind of back this off a little bit So we'll make the wheel come out, and we'll say that that goes a negative 2.5. And then we'll have it come down a negative 2.5. Whoops, too many points. 2.5. Perfect. And then we'll choose OK. Notice that the X and the Y distance is being recorded. So it's going to come out and down. So the thing is that this is going to move diagonal because it's only one move. If we want to do two moves, we'd have to move it one direction, stop, move it a second direction. If we want to move it diagonal, I can do it all in one. So I actually want to do it in two separate steps. So it's X direction first at 2.0, and we'll choose OK. And now we'll move this wheel again in the Y direction, negative 2.5, and choose OK. So why did I want to do that? Well, the wheel, we want the wheel to move after the pin gets pulled. And it might extend longer. And so as you can see on the storyboard, I'm able to change the sizing and the spacing. Now, these arms, theoretically, the arms are welded to the bottom of the plate. However, we could actually move those also. So we can grab the arm and we can move the arm out, or we can move the arm back. And so if we move the arm out, we can move it out 1.5 inches. And we can move this arm out 1.5 inches negative. And so when we look at it from the front view, everything's exploded and has their space. From the isometric view, we have a pretty good view. Now in the storyboard, things are kind of jumbled up here because the arms aren't moving and the wheel's not moving, but we can't move the arms until the wheel is out of the way. And so you have to think about that and how long it may take the arms to move. And you kind of want things to line up as you do this. And so you can actually play this from the beginning. It's all assembled. Hit the play button. So it spins, comes out, those come apart, and then that explodes. And so with the different camera views, and you can see that I've got two different camera views set up, I noticed that I can start the arm movement earlier. And I could probably even shorten the wheel movement back. And I can move these back. Let's see how this looks. And so what you're doing is you're kind of creating a video of how this thing gets exploded. And that video is one of those things, or one of those tools, that you're able to use as part of the animation. Alright, so let's try this again. We'll slide this all the way back, start play. Have a camera view so it spins it around so we can see it. The pin's coming out, the wheel's moving away, that's moving perfect. So that looks really good. So now we've got our animation. Again, hit the save button. We're going to call this animation as our user save. So now we've got the animation with the exploded view of the components, and we have the assembled view of the components in the design. So now the third thing we have to do is create drawings. And notice that we have two options. We can create a drawing from animation, or we can create a drawing from a design. So let's first create a drawing from the animation. So the storyboard 1 is what we're working on. That's what this is called, storyboard 1. The template is a scratch template. It's a new drawing. It's a B size, and the units are in inches. And its ASME is the standard for the dimensioning practices, and we'll choose OK. So now it's going to create this drawing from that exploded view. And there it is. But what if I don't like that view direction or that view angle? Can I manipulate it? Of course you can. I can also make it solid, and I can shade it. Right now it's half scale, 1 to 2. But we have the ability to change the orientation here. So if I want to choose a different direction, okay, that happens to be southeast isometric, northwest isometric, northwest isometric. I like that. Now it's still half scale, and I can choose that it's going to remain shaded as part of this option. We'll choose OK. So now I've got an exploded view. I can also add additional drawing views to this, and so I can add another base view. And this is going to be a model view, but this model view is going to be 1 to 2, and it's not the front. Let's go ahead and create the northwest isometric. Exactly. So now you can see the assembled view and the exploded view all in one space. Uh-oh, I forgot to shade it. So if we select it, right mouse click, I can edit the view, and then I can choose the shading on it. So now we're going to add the detail sheets, and I won't add all the detail sheets, I'll just do one. And the easiest way is to do a quick add on the bottom. Creates a new sheet for us. And so what we're going to do is create a new base view. And so we select the base view, and that base view is going to be of the model, not of the exploded animation, but of the model. And I'll select the model location. What's interesting is that I also want it to be full size. So I'll edit the full size, and we want visible edges and hidden lines and so forth. So we won't hide any of or shade anything. And so at this point, students are usually pretty concerned. What we need to do is turn everything off that we don't need in this particular view. So you can see the visibility check marks. We don't need the wheel, we don't need the shaft, we don't need arm number 2, and we don't need the top plate. So all we're doing is the arm. Perfect. Now I can project the arm to the top view, and I can project an isometric view of the arm. Choose OK. The isometric view, I can edit the view, shade it, and then close. I'm now able to put annotation on it, and so adding dimensions, and there's a variety of dimensions that I can do with this. So I can add radius dimensions, and I can also add overall dimensions, on the part, and then I can put in center marks and use the center mark to help us locate geometry and dimensions. So from here to here it's 1.75. From there to the center, we actually need to draw center line in, so we'll need to draw the center line in. And so you can see how it will work for us. So from this line to this line, we draw the center line, and that line is a true center line location. We can drag the edges up. And then we can dimension to that center line our values. So from the center line of the part to the center of the circle, 1.07. So you can see how you can use that as a tool to dimension and to work with. All right, so the rest of the drawing and dimensioning capability is the basic structure. What I wanted to show you how to do was to create one drawing sheet with the exploded and the assembly, one drawing sheet with a detail drawing. Creating the parts list is really simple. Under tables, we'll create a parts list table of the exploded assembly, and we'll set that parts list table here. Notice that it automatically places the balloon when we do that. And we can, again, everything's changeable, you can edit and position the balloons and so forth. So it's a simple process to do parts lists. And you can edit the parts list, take out the description. You can add a description if you need it. Again, it's your call. It takes the name of the folder or the project that you type in. So be aware that capitalization does matter. And so it does bring your name in, brings in the date, it automatically scales it, tells you how many sheets you're working with. So again, it's a fully integrated process. When you're finished, you'll want to output your drawings to a PDF. So you choose the PDF option. Make sure you choose all sheets, so all the sheets go out to a PDF file. And it would be a good idea to export the line weight, so thicker lines, thinner lines are actually viewed properly. So it's really simple to create that drawing sheet pack that you're going to submit to your instructor or send to your client. Have a great day. We'll talk to you soon. Bye now.